Bismillahirrahmanirrahim. Assalamualaikum. Nama saya Fahmi Castello bin Hafiz. My matrix number is 74774. Today, I'm gonna speed running all the 5 questions from question solid 1 revision exercise. I hope you guys can understand dan faham agar kamu orang dapat buat next solid question dengan mudah dan senang. So, dalam 5 question ni, antara 5 question yang saya akan ajar nanti adalah question 3, question 9, question 13, question 16 and question 18. Okay, tanpa membuang masa, let's go. Okay, kita mula dengan question 3. So, dengan di sini kita dapat mencari semua informasi, iaitu rod AB and rod BC, the diameter is 5mm, the load of P is equal to 2 kN, and the theta is 60 degree. We need to find normal stress, average normal stress in each rod. So actually we need to find the normal stress of rod AB and rod BC. So each solid student should know that before we start to do all the assumption or do the cara langkah, kita mestilah buat force body diagram, FBD diagram. So this is the solution. This is the FBD diagram of this question. They make it simple so that we can easily to understand. Okay. So to find the average normal stress, kita mestilah cari berapa the force of FB and the force of BC, the rod. We can see here it is equilibrium. Automatically, if we hear about equilibrium, the equation will be total Fx equal to 0 and total Fy equal to 0. So this P is horizontal, so we can do the equation total Fx equal to 0 first rather than Y, because it's easily to get the force AB first. So here is the by using the equation of total Fx equal to 0, this is the solution for rod force AB, which is force AB is equal to 2.309 kilonewton. After that, we can proceed to total Fy equal to 0, so that we can find the force BC. So this is the solution for the rod FBC. So the force for FBC is equal to 1.154 kilonewton. Sudah kita dapat force AB and force BC, we can straight to the forward to find the average normal stress in each rod AB and rod BC. So we know that the area is the diameter is given. We're using the area equation, which is cylinder area, pi over 4 to the r square, the diameter square. So the area of each rod is the same, which is 1.963 power of -5 meter square. So here dah kita dapat cari area, dah kita dapat cari force AB and force BC. We can go straight to find normal stress, average normal stress, by using the normal stress equation, which is force over area is equal to normal stress. So we simply put force AB and force BC into the equation and the area into the equation. So this is the solution to find normal stress for rod AB, which is 117.626 MPa, and the normal stress for rod BC is equal to 58.787 MPa. So this is the answer for determine the average normal stress in rod AB and rod BC. So for the second question, is little bit tricky, which is the diameter is same, is 5mm for both rod, but the angle, we need to find the angle of theta of rod BC, so that the average normal stress in rod AB is 1.5 times than in rod BC. So basically yang kita tahu ni bahawa rod AB is sama dengan 1.5 rod BC, dia punya average normal stress. Since P dia tidak dibagi, yang dia ada dibagi adalah the average normal stress in each rod is not allowed to exceed 100 MPa. So maksudnya maksimum yang this rod can handle adalah hanya 100 MPa sahaja. So from di sini kita dapat kumpul semua informasi masuk dalam the question. So since kita tidak tahu berapa P, berapa theta, yang kita mesti cari adalah the angle of the rod PC. So all kita gather semua information, which is the diameter of AB and BC. Rod AB and BC is equal to 5 mm, and the normal average stress for AB is equal to 1.5 normal stress of BC, rod BC. So here dia cakap not allowed to exceed 100 PA. So we can assume that normal stress of AB is equal to 100 MPa. So we can also find berapakah the normal stress for BC. Since we know already, we can assume that the normal stress of AB is equal to 100 MPa. So we masukkan, then the total or normal stress of BC is equal to 66.67 MPa. And then also we need to find the area, and the area is the same, which is 1.963 to the power of -5 meters square. So by using the equation of normal stress, average stress equation, which is force over A, we need to find the force first, so that we can use Pythagoras theorem or to find the angle of it. Alright, so di sini kita guna the equation of normal stress, normal average stress, which is F over A, force over area. So we just terbalik, dapatlah the force is equal to normal stress times the area. Here I label it P for rod AB, so we can find by using the equation, which is here we can see the total force of rod AB is 1963 Newton. Meanwhile for rod BC is 1309 Newton. Here I label it that we should not exceed 100 MPa. So as you guys know from previous question, it is equilibrium. This rod diagram is equilibrium. So we can find how many the data by using this equation, which is the force of BC minus the force of AB cos theta, which is the horizontal upward, and minus the downward is equal to 0. So you can find here to using this cos theta is equal to PBC over PAB, which is 1309 over 1963. So here you can conclude how many theta, we can conclude that the theta is 47.93 degree. Okay, so we already found how much the angle, and then the last question is what is the lot of P. So here I emphasize not exceed 100 MPa. So by using the equation of total Fx equal to 0, P minus PAB sine theta is equal to 0. So we can directly find P by using this equation. So for the solution so for the solution of finding P is equal to 1457.80 Newton. So that is for the question 3. So moving on to question 9. You can pause the video to read this and understand this question first. Okay, so let me continue. So here we can find the diagram, which is a square, and it will stretch out, become a shape of rhombus here. So the degree, how many angle from the angle of ABC here is already stated, which is 91.5 degree. And the perimeter of this square is, and the rhombus also given, which is 53mm and 50mm. Here we need to determine the average normal strength. Okay guys, jangan panik dahulu. Kita boleh solve this question. Very easy and very simple actually. So first thing first, as a student solid, we should draw a normal FBD diagram. But here we know that dia stretch out, become a little shape of rhombus pergi ke kanan. So kita terpaksa buat dua FBD diagram. So ini adalah solution of the FBD diagram of this question. Ada dua. So kita selebihnya dahulu kita kumpul semua informasi supaya kita boleh main puzzle-puzzle dapat out dengan cara mudah. So here kita dapat cari berapakah length of AB CD by using the Pythagoras theorem, which is 70.71mm. And here we need to find how many angle of the side of each side. So we know that it is a rhombus. So yang di bawah tu adalah 91.5 degree. Automatically atas is also 91.5 degree. So total of all degree inside is 360 degree. So we can solve it from the theta at D and C, which is same. So the theta of CD is equal to 88.5 degree. So by using a cosine rule, which is A square equal to B square plus C square minus 2BC cos A. Saya harap anda masih ingat ini equation ini, because equation ini kita sudah belajar from sekolah menengah lagi. So here adalah kita mesti terlebih dahulu cari the CD and also the CD, BD, AB, and when you find all already the length, we can find the average normal stretch of each of them. So here is the solution to find CD and BD and AB. Okay. Selepas anda mencari semua the information, which is CD is equal to 79.58mm, BD is equal to 48.38mm, AB is equal to 70.81mm. Dah kita dapat cari ini, kita dapat cari AB, so that we can find berapa the elongation, so we can find the normal average stress. So dah kita dapat cari length of CD and AB. Terus kita dapat go ahead to find average normal strength. The equation of average normal strength is elongation minus length, the original length. So here is the solution. Ini adalah solution untuk mencari normal strength antara AB dan CD, which is the normal strength, average normal strength of AB is equal to 1.414 to the power of negative 3 millimeter, and also the average normal strength for CD is equal to 0.125 mm/mm. Agak complicated, tapi saya harap anda faham dengan cara ini. One by one kita mesti terlebih dahulu kumpul semua informasi supaya kita dapat solve dengan cara mudah tanpa sesat ke mana. Ya, gitu. So moving on to question 13. So you can pause this video sekejap supaya anda boleh faham dan memahami apa situasi keadaan. Okay, let's go, continue. So di sini kita dapat melihat macam mana berapa perimeter and berapa panjang of this rod, and this rod bawah, dan ada this bar di sini, bar AC here. Yang sudah given 0.75 mm here and here to know di mana posisi force of P. So here kita dapat tengok, kita dapat baca bahawa the load of P is equal to 80 kN, the diameter of the strut, which is 40 mm, di atas ni adalah 40 mm, yang di bawah the post one is 80 mm. So the thing is, what we want to find is the angle of tilt of the beam when the load is applied. Bila P ni dah applied, kita mesti cari berapakah dia akan tilt, berapakah dia akan sengit antara this bila P sudah applied. So sekali lagi saya ulang, as a normal solid student, we should do FVD diagram. And also before we do that, the question also provide, dia bagi graph dan boleh bagi informasi tentang berapakah tension and compression. So let's proceed to FVD diagram. So this is the solution for the FVD diagram. Make it simple and easy to understand, and also make it jelas supaya anda tahu dari manakah apakah of informasi yang diberi. So since we know here, kita mesti cari berapakah dia tilt. So sebelum kita mesti cari terlebih dahulu berapakah dia punya normal strength of CD, and normal strength of AB, and also normal stress of AB, rod AB, and also normal stress of BC. So that we can find, nanti kita sudah dapat cari, kita guna equation the elongation, so we can find the angle nanti. So first thing you can see here, ada bar and then ada strut, and the force is the middle of the bar. Dan saya boleh bagi ada the parameter with 0.75 mm di tengah. So from here we can see there's a moment over here. So this is the FVD diagram to find the moment, supaya kita dapat cari the force is the strut AB and then the rod BCD. So here we know that moment is equal to 0. Okay, the force is di tengah, so we can find berapakah di sini dan di sini. So this is the solution to find each force exert on side to side, which is X equal to 4 kN. So as saya cakap tadi, saya bilang we need to find the normal stress of AB, the normal strain of AB, the normal stress of CD, and also normal strain of CD, so that we can find the elongation, and also we can find the angle nanti. So this is the solution to find each normal stress and normal strain, which is the normal stress of AB is 31.83 MPa. The normal strain of AB is 0.009885 mm, and also the normal stress of CD is equal to 77.95 MPa, and the normal strain of CD is equal to 0.002471 mm. So here we can use the equation of elongation, which is the normal strain over length that times length, which is equal to 91.771 mm for AB, and for CD is 1.236 mm. Here automatically we can substitute the angle to find the angle, how much the tilt. So di sini terdapat cari the total angle dia turun, which is 86.427 degree. The rigid beam supported AB and CD is made from this material determine the largest load P that can apply to the beam when the diameter of the strut is 12 mm and the diameter post is 40 mm. So yang dia ubah sahaja adalah yang di strut, yang di AB dan juga di CD, which is di DAB is equal to 12 mm, dan padahal di DC is equal to 40 mm. So di sini kita guna straightforward, kita guna cara mudah, which is using the normal average stress equation, which is force over A area. So kita sudah tahu berapakah dia punya normal strength of each strut, the AB and CD. So we just find it using the equation. So ini adalah solusinya, iaitu P for AB is 11.3 kN and P for CD is equal to 239 kN. Dan itu sahaja for question 13. So ini adalah question 16. Sila pause atau berhentikan video jika anda hendak membaca dan memahami apa soalan kehendak. Okay, jom let's go. Kita teruskan. So soalan ni adalah the A36T wire AB has a cross-sectional area of 10 mm square. So di sini kita dapat lihat wire ni mempunyai diameter sepanjang 10 mm square. And then so kita teruskan. So soalan ni adalah the A36T wire AB has a cross-sectional area of 10 mm square. So question ni dah dibagi berapa area for the wire, which is 10 mm square. Dan apabila dia unstretched, dia punya angle of theta is 45 degree. So soalan ini minta berapakah load diperlukan, determine the applied load P needed to cos theta equal to 44.9. So maksudnya berapakah amount of load dia perlu supaya the theta would drop to 44.9 degree. So ini question membabitkan elongation and stress. So as you can see, so seperti mana kita, so seperti apa student solid selalu buat sebelum mula-mula adalah gather semua informasi dalam satu tempat dahulu dan buat FBD diagram. So ini adalah contoh FBD diagram dan semua informasi yang terdapat dalam question tu. So anda tertanya, sekiranya anda nampak A36T wire di mana-mana question, sila tuliskan punya standard adalah 200 GPa. So initial dia masa-masa dia unstretched is 45 degree. Then selepas apply load P, it will become drop by 44.9 degree. Keep in mind, anda harus berhati-hati bahawa the bar 400mm is unchanged. Yang berubah adalah the wire AB, kerana wire AB yang can stretch and unstretch. Yang lain will kekal unchanged, which is the height of the 400mm and the length of the bar will be constant and same 400mm. So terus terang kita nampak triangle, kita boleh menggunakan using cosine rule to determine the length of the wire first when it unstretched. Kita mesti cari berapa panjang the wire when it unstretched dahulu, and then after that we need to find the length of the wire when it stretched, when it applied by load P. So dengan menggunakan cosine rule, we can find the stretch and the unstretched wire AB and the stretched wire AB. So here's the result of the the length of stretched wire AB and unstretched wire AB, which is when it's stretched will become 566.67mm. When unstretched will become 565.68mm. So from here we directly cari the elongation. So menggunakan formula elongation, kita dapat mempunyai 1.75 exponent negative 3 mm. So here kita sebenarnya nak mencari load P. Berapakah load P applied when it cause 44.9 degree. So kita perlu mencari dia punya stress dahulu. So menggunakan formula stretch dan menggunakan informasi daripada elongation, kita dapat mempunyai 350 MPa. So di sini untuk mencari load P, kita boleh juga menggunakan equation moment, since ada membabitkan moment di sini. So dengan menggunakan equation moment, kita boleh buat satu equation dahulu. So P here, you can see, you can use this equation first. Dan selepas tu kita juga boleh menggunakan equation stress. So ini adalah equationnya. After that, kita mestilah mencari berapakah force FFB. Dengan menggunakan formula stress, we can find that kita sudah ada area which is the 10 mm square, and then we can just masukkan dia punya stress dari equation atas dan masukkan, so supaya kita dapat jawapan kepada force AB which is 3.5 kN. Then masukkan 3.5 kN pada equation 1 tadi. So akhirnya kita akan dapat berapakah load applied at P, which is P is equal to 2.47 kN. Akhirnya kita dapat jawapan P equal to 2.47 kN. So for the last question 18. Okay, sila pause supaya anda boleh membaca dan memahami apa soalan kehendak. Okay, kita teruskan. So the three suspender bars are made of A36 steel. So kita tahu A36 steel is equal to 200 GPa. Equal cross sectional area of 450 mm square. So question ni dah dibagi berapa cross sectional area for the both tiga bar tu, bar AD, bar BE dan bar CF, which is 450 mm square. So soalan diminta adalah determine the average normal stress in each bar if the rigid beam is subjected to the loading shown. So kita kita melihat berapakah mount force in which position, which you can see 50 kN dan 80 kN. Berapakah average normal stress in each bar? So sini kita mesti mencari berapa force of it, berapa average normal stress of bar AD, bar BE dan bar CF. So kita teruskan. So normally kita haruslah buat FPD diagram, wajib supaya kita senang untuk solve one by one each problem. So ini adalah contoh FPD diagram yang saya sudah lukis. So di sini terlebih dahulu kita boleh mulakan dengan menggunakan equation total Fy equal to 0, since tidak ada force Fx berlaku. Kita teruskan dengan force. Kita boleh teruskan dengan total Fy equal to 0. So kita let's say the equation will be FAD plus FBE plus FCF minus all the forces included, which is 50 kN and 80 kN. We can also use equation moment, since there's a moment involved here. Ada moment berlaku di situasi ini, so kita boleh menjadikan sebagai FBE darab 2, FCF darab 4 minus all the forces total here. So kita mula-mulanya kita buat equation one by one terlebih dahulu. Okay, sambung dengan gunakan equation elongation. Kita juga mempunyai equation baharu, which is this one. So apabila kita menggunakan equation XILOT, kita mampu mempunyai mengeluarkan satu equation baharu, iaitu FAD plus FCF equal to 2FBE. Okay. So, apabila kita sudah kumpul 3 equation, iaitu equation 1, equation 2 dan equation 3, kita boleh selesaikan semua equation and then dapat menghasilkan jawapan berapa force of each member, which is in bar FDE is equal to 43.33 kilonewton, for FAD is 35.83 kilonewton, and FCF is equal to 50.83 kilonewton. Sebenarnya kita belum habis lagi menjawab soalan kehendak, iaitu we need to find the average normal stress in each bar. So kita haruslah menggunakan equation average normal stress for each member, iaitu member FBE, member FAD and member FCF. So dengan masukkan the area and also the each force of the each bar, kita boleh menjumpai jawapan, which is for average normal stress for bar BE is 96.3 MPa, for bar AD which is 79.6 MPa, and for bar CF is equal to 113 MPa. So don't panic, we can solve it one by one, slow, so that we can understand easily. Pelan-pelan kita buat supaya nanti kita dapat hadam one by one apa soalan kehendak dan dapat menjawab dengan senang lenangnya. So, don't forget, kalau ada sekiranya ada apa-apa kesalahan, bolehlah type di komen, kerana tidak semuanya manusia adalah perfect, dan saya pun bukannya setaraf cikgu, dan saya juga adalah student. So saya harap anda memahami. Kalau saya ada silap, tolonglah chat di komen, tolong betulkan apa kesilapan saya supaya saya tidak mengajar secara sesat. So itu daripada saya. Terima kasih. Saya harap anda lulus dan belajari solid dengan mudah, dan have fun with solid, because solid is nice to learn. Okay, thank you for me. Arigato and sayonara. Terima kasih. Assalamualaikum. Dari Fahmi Castello, Hafiz, dan itu sahaja.